Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 6 Learning Target 7. Today we are talking about compound interest. So before we get into the compound interest equation and how we use it, we are going to review exponential equations and how we would write them and what kind of key information we look for when we're reading a situation. So in this example, it says in 1982, there were 84,105 females in high school sports. Since then, the number has increased an average of 9.4% per year. Part A asks us to write an equation to represent the number of females participating in high school sports since 1982. And then Part B says, according to the equation you wrote, how many females participate in sports in 2005? So the first thing that we need to do, we are going to write an equation. This is just a blank regular equation with no t values substituted in. So we're just writing the plain old regular equation. There's two things that you need to know. You need to know the C and you need to know the R. That's the starting amount and the growth rate. So in this case, the starting amount is 84,105 females. So that's my starting amount. The other thing that we pay attention to is this 9.4%. That's my growth rate. However, it has a percent sign, which means I need to take that decimal and move it back 2 places before I put it in my equation. So when I do that, I'm going to get R is equal to 0.094. The other thing I recognize about this equation is the fact that it says increased. Increase tells me that it's growing. This is growth. That means I want that 1 plus the R in parentheses for my equation. So my plain regular equation is going to look like this. Y equals 84,105 times the quantity of 1 plus 0.094, all raised to the t power. And remember that T stands for time. So this is the regular equation. I can now plug any amount of years into that T and figure out how many athletes there were in sports. So I'm going to go ahead and do that in Part B. Part B asks me, according to the equation that you wrote, so we're going to take this equation and use it down here, how many females participated in sports in 2005? So what I need to do, I can't just take 2005 and plug it in for T. That's not what's happening here. What's happening here is how much time has passed from 1982 to 2005. So that's what I'm going to figure out. How much time has passed? So the way I figure that out is take 2005 minus 1982. So if you don't have it out yet, go ahead and grab your calculator. I'm going to grab mine and do the subtraction here just because it makes my life a lot easier. I could do that in my head, but why not type it in my calculator if I can? So there have been 23 years that have passed from 1982 to 2005. So I'm going to take that 23 and I'm going to plug it in for T. I have Y equals 84,105 times 1 plus 0.094 raised to the 23rd power. Now, I can go ahead and type that whole thing into my calculator all at one time as long as I'm careful with my parentheses. So you're going to type 84,105 times, then open a parenthesis and type 1 plus 0.094, close your parenthesis, then hit the caret key, that's that little arrow pointing up, and then raise it to the 23rd power. When I do that, I get this amount. I get 664,079.7251. Now, this is people. Okay, I'm looking at females in sports. I can't have a partial person. So I'm going to use that 7 to round this number up. And that 9 actually goes up to, instead of this being 79, this is now going to be an 80. So I have 664,080 athletes, female athletes. All right. So that's just a refresher on the exponential growth equation. Now, we're going to get into compound interest, which is a form of exponential growth. Compound interest has its own equation, and there's a couple of extra pieces to it, so we got to be a little bit careful about what we put into that formula. Here's what the formula looks like. It's A equals P times the quantity 1 plus R divided by N. That's where things look a little bit different. So this r divided by n right there is a little bit different. And then it's all raised to the n times t power. Okay, so there's that extra piece of the n. Our regular exponential growth equation looked like this. Y equals c times 1 plus r raised to the t. Now you've got these extra added pieces of r needs to be divided by n, and n gets multiplied by t up in the power. Now you're probably thinking, what is n? Where does n come from? Here's what your variables are. So the rest of the variables are pretty much the same. Now they call them different things because it's compound interest instead of just regular exponential growth, but they pretty much are the same thing. So A is your ending amount. Okay, that's like your account balance is kind of where they get the A. P is the starting amount, or in other words, principal. That's where that P comes from. Okay, so the principal amount or the starting amount, and those two are the same as the Y and the C in compound growth or in exponential growth. The variable out on the left-hand side is the ending amount. The first number that you see in the equation is the starting amount. Okay, normal, regular. R is still rate, same as before, and you don't want to write it as a percent, you want to write it as a decimal. Sorry, that's a mistake there. If that says percent on your paper, change that to decimal. You want to write your rate as a decimal. So whatever the interest rate is, change it to a decimal. T is still time. Time is measured in years for compound interest. Now here's the new one, okay? So the new one here is N. Now N is the number of times that something is compounded per year. Number of times that something is compounded. Okay, so look, that's the word you're going to look for, is that word compounded. So when you see the word compounded, what they're talking about there is how many different times do they calculate the interest per year. So if they compound the interest monthly, that means that they compound it 12 times a year. If they compound the interest daily, that means they compound it 365 days or times per year. If they compound it quarterly, that means they compound it 4 times per year. Weekly would be 52, semi-annually would be 2. So that is what you're looking for when you see the word compounded. The biggest thing that people forget is to put this in both places. This N goes into 2 places in the formula. You have to divide your interest rate by the number of times it's compounded, but then you also have to multiply the number of years by the number of times it's compounded. All right, so let's just do some examples here. So it says Maria's parents invested $14,000 at 6% interest per year, compounded monthly. How much money will there be in 10 years? Okay, so here's the values that you know. You know that $14,000 is going to be your starting amount, which in this case is called the principal. You also know that 6% is going to be your interest rate, and you've got to move that decimal point back 2 places. So your interest rate is going to be 0.06. You also know that she's looking for this end result in 10 years. So T is going to equal 10. The last value that you have to find is not a number that's stated in the question. You have to kind of figure out what that number is going to be based on the word. So you're always going to look for the word compounded and then what comes after it. In this case, it's compounded monthly. Well, then you ask yourself, how many months are there in a year? There's 12. So that means your N is going to equal 12. So here's what that equation looks like. We have an ending amount of 14,000, and then in parentheses you do 1 plus, just like you did for exponential growth, but here's where you're going to take the 0.06 divided by 12. So it's not just plus 0.06, it's plus 0.06 divided by 12. Close off that parenthesis. Then up in the exponent position, you have these 2 things being multiplied together. So 12 times 10. Okay, so that's the equation. It looks a little bit different than exponential growth. It's kind of similar, but it's still got those added components of the N in there. Now, here's how you would type this out into your calculator. I like to take care of this exponent first. That's the first thing that I do. Those 2 things need to be multiplied together, so that's what I'm going to take care of first. So I've got A equals 14,000 times 1 plus 0.06 divided by 12, and then raise it to the 120th power. Okay, so when you take 12 times 10 in your calculator, you get 120. After that, the next thing that you have to type into your calculator is this, okay? So I'm going to have 0.06 divided by 12, and I get 0.005. Raised to the 120th power. So now here's where you've broken it down to where it looks like an exponential growth equation. At this point, if you wanted to type the whole thing into your calculator, you could. Now, I'm going to tell you something. One thing that I do, the one thing that I use on my calculator all the time is the second and then answer button. So you've got second and then the button answer. And answer is, for me, it's above my negative key down at the bottom. I use this all the time, okay? This is something that now that I have this typed into my calculator, here's how I'm gonna talk you through this calculator keystroke. I had the 0.005. All I'm gonna do is then hit plus 1. So I have plus 1. Then once I do plus 1, I'm gonna raise it to this power. So then I hit the caret key and hit the 120. Then after I get that, then I multiply by the 14,000. Okay, so let me write that out for you in keystrokes. These are my keystrokes here. See if I have enough room. So I start with 0.06 divided by 12. Hit enter. Then I do answer plus 1, hit enter. Then I do that answer raised to the 120th power, hit enter. Then I do that answer times the 14,000 and hit enter. And that's where I get my amount, which in this case is $25,471, and this is money, so I'm going to call it 55 cents. Okay, so that second answer button, I did 1, 2, 3, 4 steps in my calculator, but I used my second answer feature for every single one of them, and that helps me out a lot. That saves a lot of time. It eliminates the error due to rounding, especially like when you look at that answer that was raised to the 120th power, that was a decimal that was non-terminating. The decimal is going to keep going and going and going. If you cut that off and round it, you're going to lose a lot of accuracy. So this is how I type it into my calculator. All right, let's try another one. So determine the amount of investment of $300 invested at an interest rate of 3.5% compounded semi-annually for 22 years. So here's my principal amount. Here's my interest rate. I got to move that back 2 places. So 0.035. Semi-annually is 2. And then T is 22 years. Okay, so let's plug this into our equation. So I've got 300 times 1 plus 0.035 divided by 2 raised to the 2 times 22 power. Again, I like to take care of this first. So I'm going to have A is equal to 300 times 1 plus 0.035 divided by 2, raised to the 44th power. Here's where I use those keystrokes. So this is how I will type this in. I'm going to take the first one, 0.035 divided by 2, and hit equals. 0.035 divided by 2, and hit equals. Then I'm going to do my answer plus 1, hit equals. Then I'm going to do my answer from there. So I've done this, then I add it to this. Now I need to raise it to that. So I'm going to raise it to the 44th power. So we'll raise it up, 44, hit equals, and then one more keystroke. I've got my answer times 300. Notice that multiplying by 300 is the very last thing that I do. Even though it's the first thing that you write in the equation, all of this stuff has to come before you multiply by the 300. That has to be the very last step. So I end up with $643.63. Okay, I want you to be practicing these things on your calculator with me and see if you can end up with the same answer that I do. All right, here's number 4. Again, practice this on your calculator with me. So I start with an investment of $400. That's my principal. I'm investing it at an interest rate of 4.3%. That's my interest rate. I move my decimal back 2 places. So R is equal to 0.043. And I want to compound this annually, so my N here is equal to 1, because I'm only doing it 1 time per year, and then I'm doing this for 15 years. So T is 15. Here's your formula. A equals 400 times 1 plus 0.043 divided by 1 raised to the 1 times 15 power. Now, when you compound annually, it's really no different than an exponential growth equation, because 1 times 15 is still 15. Oops, 3 divided by 1 raised to the 15th power. And 0.043 divided by 1 is no different. 0.043 divided by 1 is still 0.043. So, but for sake of just doing everything the same, that's what I'm going to start with. I'm going to do 0.043 divided by 1, then add the 1, then raise it to the 15th power, then multiply that by 400. When I do that, I get 752. I get 0.184912, and it goes on and on. Now, this is, I didn't talk about the rounding yet, but here's where you're going to want to round. This is all money. The amount of an investment, we're in dollars here. So dollars, I want to end at the hundredths place, which means I use the 4 to round the 8. So this is $752.18. Always label it with your dollar sign. And there you have it. All right, so we're going to take a look at our last example here. It says determine the amount of an investment of $1,200 that is invested at an interest rate of 2.6% compounded. That's supposed to say weekly right there. Somehow that got typed in the wrong way. Weekly. For 13 years. So let's identify all our parts. Here is my principal amount. Here is my interest rate. I got to move that back 2 places. So that's 0.026. That's a 2 there, sorry. Here's my time, 13 years. And then compounded, you always want to look for the word compounded, and here we're doing compounded weekly. So weekly, I have N is equal to 52, okay? So my equation looks like this. A equals 1,200 times 1 plus 0.026 divided by 52 raised to the 52 times 13 power. Okay, so I'm going to multiply those two together. I like to take care of that power first. So 52 times 13 is 676 there. A equals 1,200, 1 plus 0.026 divided by 52, raised to the 676th power. All right, so now here's where I'm going to go through those keystrokes, okay? So the keystrokes, I'm going to start with 0.026 divided by 52 and hit equals. That has to be the first thing. That's inside my parentheses, and it's a division inside my parentheses. So I have to do the division before the addition. Now, when you type 0.026 divided by 52, you might get some scientific notation there. That's okay. Just leave it. You're still going to hit +1. So answer +1. And that's 1.005. Then you do that raised, so that answer raised to the 676th power, that's 1.402, and it goes on and on. Don't cut it off. Don't clear your calculator. Just hit times the 1,200, and I get the 1682.42648 ... And I'm going to round my answer to the nearest pennies. So I want to round to the 2, so I look at the 6 to decide the 2, and that's $1,682.43 there. Don't forget your dollar sign. And that is my amount at the end of 13 years. All right, that takes us to the end of our notes for today. Thanks so much for tuning in, and I will catch you next time.